250 miles per hour. That's what this machine is designed to simulate. Today you're going to see me turn this pile of aluminium extrusions, steel shafts and nuts and bolts into a fully functioning tyre shredding machine. And then we're going to fire it up. And as usual, things didn't go completely to plan. Oh my god. In episode 2 I designed a machine that simulates the demands of a 250 mile per hour speed run inside my garage using science. This rig will let me test wheels, tyres and motors in a controlled and repeatable way before risking everything on an actual run, helping me towards the 250 mile an hour goal of Project 250. I've got the CAD, I've got the materials and I've got the parts. Now it's time to build. We've got a lot to get through, so let's start with the framework. There are a lot of parts in this rig. First job, cutting the aluminium extrusions to length. Marking up, clamping down, out with the jigsaw and then lots of filing. Honestly, the results were surprisingly good. Then it was on to drilling. I marked everything up using my trusty 3D printed templates. They've saved me more time than I can count. But before drilling, more cutting. Now it was time to go big. These plates need clearance for the pivot shaft and the flywheel spindle. 4 large holes in total. First attempt, not enough clamping. Lesson learned. This was much better. With a slow feed, steady pressure, letting the tool do the work. There were loads of parts to make. More marking, more cutting, more filing. The amount of swarf was honestly impressive. This is the glamorous side of engineering that no one talks about. By now I had my drilling dialed in and I'd perfected the technique, but I drilled the last hole. Typical. Quite centred as well in the end, not too bad. The pivot shaft was simpler. Cut to length with a special blade for aluminium, which absolutely munched through it. Oh yeah! What a clean cut. Quick deburr, job done. Before assembly, I made the floor rails. And yes, the manky sheets are deliberate. Aluminium swarf gets everywhere, every single nook. Right, that's most of the hard work done, and the tidying up. Now let's talk about the heart of the rig, the roller. In episode 2 I explained why this part is critical. Go back and have a look if you want to know why. So how did I bring this to life? Let's rewind a couple of weeks. PCBWay is best known for making PCBs. But they also have loads of other manufacturing services on offer, including CNC machining and 3D printing. For the roller, I uploaded my CAD model, selected the material and instantly got a quote. That was incredibly useful for quick cost comparisons between steel and aluminium, diameter changes, all instantly quoted. And if you need tighter tolerances or threads, you can upload a drawing and usually the price barely changes. You can choose from plastic, aluminium, steel, titanium, pretty much anything and with any finish. Shipping can add a bit, but it's fast, trackable and you can prepay import duties for convenience. Overall turnaround usually 1 to 2 weeks, which is amazing. I'm super pleased to have PCBWay's support on Project 250. They were a crucial part of the Beast Car project. And every time I've ordered from them, I've been blown away by the quality and value of their work. Getting the parts made by PCBWay for the test rig and the car itself is a must for me. There's a link in the description so you can get a $5 voucher towards your next project. I definitely recommend giving them a try. When this arrived, it looked incredible. But how balanced was it? In episode 2 I mentioned how balance would be critical with the roller turning at over 15,000 RPM. So I got it on the prop balancer. Put a little mark on it, we can see a bit better. So yeah, if I move that to different positions it just doesn't move. No movement, but was the balancer sensitive enough? So what I'm going to do is stick a weight on it now and see if that makes any difference. 5 grams added. Nothing. 15 grams added. It moved. Back to 10 grams, it still moved. So that means the roller is balanced within 10 grams. Maybe well within that, or even perfectly. For a 5 kilogram flywheel spinning at 15,000 RPM, that might be okay. I even tried this ridiculous spring and bearing setup. Same result. I've made another balancer that's not quite good enough, unfortunately. So I decided, good enough, carry on and see how it works. Let's build. Now it's time. Cue the montage. The moment of truth. Yeah, that is super smooth. No wobble, just perfect rolling. Pretty soon the framework was together and it looked serious. This thing is looking awesome. Let's spin the roller. There we go. Super smooth. Time to get the drive motor in and the wheel on. I've just got to the exciting point where I'm going to put a wheel on this for the first time. Under load for the first. God, there's really good grip there, even without any weight on it. Once that's got a bit of weight on, that's going to grip just on the steel, no problem. Then, the first problem. The tyre was running wobbly. It's not running true. The rim's moving, you can see. Turned out to be the modified compact adapters I'd bought. I switched to my DIY Beast adapter and the problem was solved. Homemade wheel adapters on and it's about 10 times better. Lesson learnt. Sometimes your own parts are better. Perfecto. I added the encoder motor for speed data logging. When everything lined up perfectly, that was deeply satisfying. Oh! Oh yes! It might work, it might work. This is what just happened when I slid that in. It's probably not going to come out very well on camera, but it just went on. That's insane. This is cool, got it all tightened up now, and it looks like it's going to work. Oh yes. Then there was loads of wiring to do. But first, I couldn't resist making a nice little bracket to mount the two vesc units very neatly, one above the other. That moment when you apply power is always nerve-wracking.
And it's looking all happy, yay!
But of course it didn't work.
Minor teething issue that I've come across is the encoder's not working on this is on the back of the drive motor there. I think it's because there's a big gap between the magnet, which is sort of in there, you just about see me poking it, and the sensor, which is on the other side of this PCB. That's the difference. So taking a bit off the length of them means this can sit closer to the magnet.
I tried reducing the gap, but still it didn't work.
So it's working. You can see it's sitting close to the magnet already. Right.
It must be the extended wiring harness allowing signal interference.
Just done some very fiddly soldering on that little board here to change it to work on 3.3 volts. So I'm about to power it up and I'm worried it could be a smoke show. So I'm making sure I film it.
And deep breath and power on.
No smoke, that's good. Any warning on the vesc? No. Yes. It's working. It's working.
Of course I had to spin it up.
There we go. Awesome. Yes. Yes. That is very cool. Flywheel is not vibrating at all. That is amazing. Holy moly.
Wheel spin everywhere.
Full speed on 6L.
That was 97 miles per hour on my workbench.
Oh my god. That was full speed on 6L, just on the bench, and it wasn't really moving, so that was good. I think we might be alright to go to 260. Whew.
As well as hitting 250 miles per hour, I have the goal of reaching 10k subscribers by the start of the speedrun season. Please consider subscribing. You won't want to miss what happens when Project 250 hits the runway. It's gonna be epic. Running it loose on the bench was sketchy, so time to bolt it down. But this didn't go smoothly. Brand new masonry bit, hammer action, 10mm in, it stopped. Concrete 1, me 0. I tried drilling the holes and the drill would only go in about 10mm before it just completely stopped because the concrete must be just ridiculously hard. What am I going to do then? Well, I had a bit of a backup idea, and that was to use a solid block of wood with a big surface area bonded to the garage floor. And that should give a pretty sturdy base for the rig to sit on. Alternate plan, glue bits of wood to the floor. Yes, I glued wood to the garage floor. But it worked. Now it had a permanent home. Now it was time to get the weights right. 0.855 kilograms, right. And I want to get 2.5 to 3 kilograms, so I'm going to bolt a weight on there and remeasure it. Quite a long screw, a bit annoying, but you know, use what you've got. 2.9 kilograms, I think that's quite good. 2.3 kilogram plate added, just right. Time for some proper runs. Oh my god. I found bouncing. Whoa. So I tried reversing the rotation, which worked, mostly. It still bounced when slowing down, but it still did 95 miles an hour. And then I tried 12S. Blown tyre, but that was 180 miles per hour in my garage. You could hear the wheel spin. We need more grip. Well, that was definitely a bit of excitement this evening. Getting up to probably 180 mile an hour, something like that, with this test rig. And it's going pretty well so far. I think all I really need is to get a bit more grip on the roller. I was originally going to stick some sandpaper to it, but I just think it's going to come off. So I'm thinking now of mixing up some fiberglass resin, put some sand in it, and then basically just spread that on the roller, so it's got like a sandy high grip coating. And hopefully that'll give it a bit more traction, because it just spins up at the moment. Got some good data though to go away with, so yeah, things are going all right. The fiberglass resin idea evolved into epoxy primer, but before I stuck anything to the roller I needed to make sure it wasn't going to come off at 15,000 RPM. So I came up with an idea for a test. Get a piece of steel and grind it so the surface is fresh, then stick sandpaper to it with superglue and epoxy to primed and unprimed areas. And try the sand and primer idea at the same time. I've worked out that for this to survive the roller rotating at about 260 miles an hour, these need to take about 10 kilograms of force before they get pulled off. So if any of them get over that, then that'll give me a route forward for using this really grippy sandpaper. And the backup option is the paint with sand in.
It went to 10 kilos before it came off. Taking the backing off the belt, that's what came off. It stayed stuck on there. Pretty good though. Right, here we go. Oh, so the super glue did not stick to the primer. There's nothing then. 0. Here we go.
The results were very interesting. The superglue on raw steel and the epoxy on primer worked the same, because they both bonded so well the surface came off the belt. So I went for the superglue on raw steel because it was easier. I was glad this worked because the sand in primer idea was nowhere near as grippy as the sandpaper. I'd decided what to do, now I had to do it. That meant roughing up the lovely smooth finish of the flywheel so the superglue would adhere, then trimming a sanding belt to size. Of course, things don't always work first time.
Oh, there's a bit it doesn't reach. Oh no. That's how is that?
Luckily, I have 3 more belts.
I've got to show this. I've just cut this to 50mm wide with a ruler and a knife, and it's come out pretty accurate. 49.88. So within about 0.1 millimetre of 50 millimetre. So quite pleased with that. Yeah, 49.9, 50.0. Just shows what you can do with a ruler and a knife. 50.0. Oh my God, can't believe that. I've just trimmed about another ½ mil off and it's absolutely perfect now. Look.
The nerve-wracking step was applying the glue and getting the sandpaper positioned on the roller. I had to be quick since it sets almost instantly. I went for plenty of glue to get a good bond, but most of it splurged out and made a mess, sticking onto the rubber bands I put around it to secure the paper in place. I cleaned it off the best I could, but promisingly, the sandpaper definitely seemed well glued. The truth will come out when I spin this thing up, which was coming very soon. I got the roller reinstalled and went for an installation run on 6L. There was bouncing and squeaking. The sandpaper seemed to be gripping well and treading the tyre nicely. Actually clamping the roller to the bearings got rid of the squeaking, but some bouncing was still there and there seemed to be a lot of friction. So before running again, I added a damper, a nice Schumacher big bore shock no less, set up with maximum damping, and double checked that all of the alignment, where I seemed to find improvement. Running on 12S with a brand new tyre, the bouncing was eliminated. And a speed of 193 miles per hour was achieved, but the foam had already blown. Anyway, the wheel slip was now almost identical to what I measured during actual speed runs. The sandpaper was the perfect choice of surface. Next, I decided to try a brand new Contact 40 tyre, which I knew would do 218 miles per hour at least in real life. With 18 cell, that's 75 volts. Then send it. This thing hit 230 miles per hour when the tyre blew.
Yeah!
Shedding foam everywhere.
Yeah!
And the damage was just like from a real speed run, shredded down the centre. Things were looking good, but then I looked at the data. Acceleration was slow. Was the roller's bearing drag causing this? I'll look into this more later. First, I wanted to see what happened with the propeller fitted. Another Contact 40 wheel, but a used one this time, again on 18 cell, and I went for it. The fan was blowing so strong it nearly knocked the camera over, so I set it up better and went again. The noise was immense and the drag was really kicking in around 170 miles per hour. But the speed plateaued and the tyre blew literally all over my garage. Looking at the graph, the acceleration was even slower. Too slow. How the rig generates drag might need a rethink before I can do my full controlled comparison test. So the rig is built. Huge thanks again to PCBWay for supporting this build. It's already proven as well. It hit 230 miles per hour, which was when the tyre let go. The slip was similar to reality and the tyre failed just like we do on a real speed run. So it can apply a realistic, repeatable load to a wheel, which is essential, oh my God, which is essential for comparative testing. But I also found that the drag load was higher than in reality. Maybe the bearings are adding more drag than I thought. With the propeller as well, it was way too much. and the inside of my garage got coated with tyre crumbs. What's next? I need to get back to design the new car. In the next episode, I'll show you where Project 250 is heading. If you want to follow the journey to 250 miles per hour, hit subscribe and I'll see you in the next one.